Good morning, Year 5. Miss Biggs here. Welcome to your Wednesday maths lesson. You record today's date and learning objective. Being careful to note today that we're going to compare and order fractions less than 1, but we're only doing the first half of the worksheet only today, please. Complete your flashback 4, pause the video and come back to me. I've given you a clue to think about how to do number 2. Let's have a look at the answers. First, how many 5s are in 18? 5, 10, 15. If it's in 3 times, to get from 15 to 18 is 3 more, 3 3/5. From here, to get from 20 to 4, I would divide by 5. So I'd do the same to the top, divide by 5 is 3. Number 3 is your answer. Number 4, adding together, there's your answer. And the time on the clock, it is 8 and 12 minutes past. So it's 8:12. On to our learning for today then. So remember, we're just going to be doing the first half only, questions 1 to 4. Let's look at how to do that. Look carefully today and do it along with me. That's really important for today's lesson. So we're going to compare and order fractions that are less than a whole one. First, let's complete our skills that are going to help us today. Pause the video, come back to me when you've done. Let's have a look at how you did. Complete the equivalent fraction. So to get from 2/5, I want to get to 20ths. So what would I do to 5 to make 20? I'd multiply by 4. So I do the same to the numerator, and that's 8. Right, the first 7 multiples of 7, that means the first 7 answers in the 7 times table. There you go. Number 3, write the first 7 multiples of 4, that means the first 7 answers in your 4 times table. And there you go. Number 4 says, what is the lowest common multiple of 4 and 7? So you look in both times table and find the one number, the first number you come to, that's in both times tables. You should have spotted 28. So the lowest common multiple of 4 and 7 is 28. Let's see how all of this will help us in our learning today. We're going to be using the symbols to compare the fractions. So 3/10, and I'm comparing it to 7/10. Let's draw it first. My parts are 10 parts and 3 are shaded. Draw again, 10 parts and 7 are shaded. You should be able to see quite clearly here that 3/10 is smaller than 7/10. When the denominators are the same, here 10 and 10, the greater the numerator here, the greater the size of the fraction. Yeah, that's true. We could also say it the other way around. The smaller the numerator, 3, the smaller the fraction. We can see that quite clearly here. Let's have a look. With this one, we're going to use our symbols to compare the fractions. But with this, you should have noticed that none of them are the same. The denominators are different. So we're going to have a think. When the denominators are the same, the smaller the numerator, the smaller the fraction. So we're going to have to change it so that the denominators become the same. Well, I won't be able to change this to 5ths because that won't divide by 3. But I could change this into 15ths. What would I do to 5 to make it into 15ths? I'm going to think of my multiples of 5, 10, 15. How many times did it fit in? 1, 2, 3 times. So to change it into 15ths, I'm going to multiply by 3. And whatever we do to the denominator, we do to the numerator. 2 times 3 is 6. Now we can compare, because 2/5 is the same as 6/15. And 6/15 is less than 7/15. Here we can see it written here. 6/15 is less than 7/15. So therefore, in the original calculation, 2/5 must be less than 7/15. Use that same method here and changing it so that the denominators are the same. Think what to do to the other denominator to make it the same, then do the same to the numerator. Pause and have a go. Shall we see how you did? In the first one, we can't change that into 6 because this won't divide. So this one, we can change to 18ths. What would you do to 6 to get to 18? We'd multiply by 3. Do the same to the numerator. That would be 3/18ths that it's equivalent to. Now we can compare those two, and we can see quite clearly that 3/18ths is smaller than 5/18ths. Therefore 1/6 is less than 5/18ths. Let's have a look at this one. We're going to change our fifths into 25ths. What would I do to 5 to make it into 25? Times it by 5. Do the same to the numerator. 3 times 5 is 15. 15 25ths. Now we can compare the 25ths, and we can see quite clearly that 12 is smaller than 15 25ths. So therefore, it's smaller than 3/5. And you should on the last one notice that 36 out of 36 means I've got a whole one. And if I've got 9 out of 9 pieces, I've also got a whole one. So actually they're equivalent without having to do any working out. Let's have a look here. He says that I know that 4/7 is greater than 5/11 without having to draw a bar model or find a common denominator. Is he right? Let's have a look at it then. He's going to use his knowledge of half. What is a half? Well, if I take the denominator 7 and halve it, I get 3.5. So if this was equivalent to a half, it would be 3.5 out of 7. This is more than 3.5, isn't it? 4 is more than 3.5. So therefore 4/7 is greater than a half. What about 5/11? Well, if I take my 11 and halve it, I get 5.5. And this is 5. That's less than 5.5. So it's less than a half. Therefore, he's correct, isn't he? Let's have a look at it and apply it to this one. 8/14 and 10/22. Here, what would half of 14 be? 7. So 7/14 would be a half. Well, this is more than a half, isn't it? So, because it's more than 7/14. What about on this side? Half of 22 would be 11. Well, this is less than half. If 11 is half, then 10 is less than half of 1. Therefore, this side, 8/14, is greater than this side, because this side is more than a half, and this side is less than a half. See if you can apply our learning a little bit further. Let's have a look on this one. I have 4/9 and 4/5, remembering to make the bars the same length to compare. Here I've got 2/3, and here I've got 2/7. Let's have a think. What's the same and what's different? What do you notice when you're comparing them? Well, you should have noticed by looking at the bars that 4/9 is less than 4/5. And you should have noticed that 2/3 is greater than 2/7 on there. So we can see here that when the numerator is the same with the denominator, if the denominator is larger, the greater the denominator, the smaller the pieces, so the smaller the value. When the numerators are the same, the greater the denominator, here 9, can you see? Then the smaller the fraction actually is. I could turn that round. The smaller the denominator, 5 smaller, the actual larger the pieces of the fraction are. Let's have a look at that. Can we apply it with this one? The numerators are the same, so therefore this must be bigger. I always think of it as if you were dividing up a pizza or a cake. If I split my cake into 3 pieces and I ate one of them, I'd have quite a sizable chunk. I'd like that. However, if I split it into 100 pieces and I've only got one of them, I'm not going to have very much of it at all. So this is obviously going to be a larger chunk than this one. It matches our rules that we found. Let's have a look at this one. Well, in this one, the numerators are not the same, the denominators are not the same, and it's quite tricky to change them over. Last time we looked at changing the denominators to be the same. What about if we could change the numerators to be the same? I could, therefore, change my 3 to become a 6. What would I do to 3 to make it into 6? Times it by 2. Whatever I do to one, I do to the other. So it will become 6/14. And here we can see that 6/14 compared to 6/11, this has got to be smaller. So this is smaller, therefore, than this, because the denominator is greater. Pause the video and have a go at these ones, applying what you know. Let's have a look and see how you did. Let's have a look at this one. Well, I could change my 3 to make it to 12. What would I multiply by 3 by to make it into a 12? I'd multiply it by 4. So I do the same to the denominator. Multiply it by 4, and that makes 12/40. 12/40 compared to 12/37. Well, these are going to be smaller pieces. So this side is smaller than 12/37. Let's have a look at this. There are 2 ways to do this one. One way would be to change that into 20/54. The other way, I could change this and make it smaller. I could halve it. Half of 20 is 10, and half of 62 is 31. I could compare that now. 10/27 compared to 10/31. These pieces are smaller pieces, so therefore this side is larger than this side. Let's have a look at this one. What could we do? We could change this to make it into 3 as a numerator, so we're going to multiply it by 3. We do the same to the denominator, that makes it into 15ths. 3/8 compared to 3/15. 15 is smaller pieces, so therefore this side is greater than this side. It's your turn, please, to have a go at questions 1 to 4 on your worksheet. And for this today, you're going to stop after number 4. And tomorrow's lesson will go on to look at the rest of the worksheet. To record this in your book, please. Here's a fraction wall to help you should you wish to pause and come back to it. I'd like you to lay it out like this. For number 1, I'd like you to cut and stick it because the bars are exactly the same length and it makes life easier. For number 2, you can record it in your book like shown. Continue to the end of question 4 in your book and then you must stop. The rest is in tomorrow's learning. Good luck for today and come back to me tomorrow for your next part of the learning. Goodbye.